Hello and welcome to the podcast on lead-acid batteries by Ramesh Natarajan. With industry experience of over 42 years, Ramesh helps battery and battery-related industries with technical inputs and provides solutions to typical problems faced by manufacturers, service personnel, as well as users of batteries and related equipments.
Hello and welcome to this episode of my podcast. Today, I shall be answering a specific query received from a battery manufacturer. This query pertains to tubular plate manufacturing. The query is, what are the reasons for the non-uniform filling of positive tubular plates? I shall explain the various reasons one by one and try to provide a solution to the problem wherever possible. The first and foremost reason for non-uniform filling is variation in the density of the blended powder. The stamp density of the powder may be checked. If the density is varying, the reason may be improper mixing of the powder or variation in the powder quality with respect to its density. Please be aware that the Scott volumeter, which only measures apparent density, is not the same as the equipment used to assess stamp density. Verification of the mixing procedure is also necessary. When utilizing an oxide and red lead blend, it's important to follow a consistent order when adding the various powders. Suppose you're adding 4 bags, out of which 2 bags of say 25 kgs each is red lead and 2 bags of 25 kgs each is oxide. And suppose your operator has been putting 1 bag of oxide, 2 bags of red lead and a last bag of oxide. You must always mix it in the similar manner. And suppose he's putting 1 bag oxide, 1 bag red lead, 1 bag oxide, 1 bag red lead, then you should follow that order. Of course, the mixer has to mix it irrespective of the manner in which you load the bags, but it may not always happen. It's always better to follow one consistent order and put the bags and the powders, add the powders accordingly. So this may be a reason and it needs to be verified. Clumps in powder filling must also be checked. When humidity is high, clumps form. This powder caking or clumping partially solidifies the free-flowing powder. If the powder clumps, break it up with a wooden spoon or hammer before adding it to the blender. If needed, sift the powder through a mesh sieve. The powder's particle size must be precise and within a narrow range. Any lumps in the powder shall hinder the smooth flow of powder into the tubular bags, that is gauntlets. Next, the set vibration amplitude may fluctuate with frequency or AC input voltage. When DC input voltage is given to the vibrator, a controller error can cause inappropriate filling. Maintaining or stabilizing the vibrator mechanism's input is crucial. Whilst on this topic, I would like to mention an incident which I had come across. A battery manufacturer faced problems with filling due to the odd behavior of the equipment which used to set itself right automatically. After a lot of investigation, it was realized that the vibrator had problems with the generator power and used to work well with the utility power. A frequency regulator, when connected to the vibrator, eliminated the problem and resulted in uniform vibration. It has been noted that some producers of batteries combine the mixed powder with additives. Although it is not extremely common, a few manufacturers do this. In these situations, the additives have to be free-flowing and their particles can't be bigger than the blended active material's particles. The active material flow must not be impeded by the addition. It has occasionally been noted that the spines have burrs, particularly in situations when the spine grids are gravity cast rather than pressure cast. This is typically caused by the grid mold's cork spray fading off. Burrs that prevent the active material blend powder from flowing freely through the spine grids are not allowed. Oil is used by manufacturers of pressure die cast spine grids to help the grids come out of the mold. Because it prevents the active material blend powder from flowing inside the gauntlet, this oil on the grid surface may also cause filling issues. Finally, but just as importantly, variations in the diameter of the tubular bags are a major cause of variance in plate weights upon filling. A deviation in diameter from the given norms might significantly change the void volume and cause chaos. Due to the bag's flexibility, measuring the diameter using a micrometer or vernier caliper is challenging. It is advised to utilize a graded mandrel. Purchasing tubular bags from suppliers who maintain stringent quality control over bag diameter uniformity and other aspects is therefore very crucial. I sincerely hope that this episode will be helpful to the listeners, and I eagerly await your feedback. Thank you.
Please do visit www.rameshnatrajan.in. Keep yourself updated about our new releases by hitting the subscribe button.